If we take the general expression for a quadratic, and these coefficients a, b, and c are found in the process of analysing the numbers that the question gives you. So let's set up an n equals 1 column, and an n equals 2 column, and an n equals 3 column. And I'm going to substitute n is equal to 1 into here and write the answer down. Then n is equal to 2, then n is equal to 3, and then we'll work out the differences. Okay, so if I substitute n is equal to 1 into here, I get a times 1 squared is simply a plus b plus c. Now for this guy, 2 squared will be 4, so I get 4a plus 2b plus c. And 3 squared is 9, so I get 9a plus 3b plus c. Okay, just as we do with the numbers, let's work out the first line. I only need 2 of them, of the differences. So we take this expression and subtract this. So we do it in a, b, and c terms separately. 4 minus a single a gives us 3a. 2 minus a single b gives us b, and the c's disappear. Now the difference between this guy and this guy. 9 minus 4 is 5a. 3 minus 2 is again a single b, and the c's disappear. Now the second difference, 5 minus 3a is 2a, and I've written it in the middle for a reason, because the b's disappear. So there we are. We've found that the second common difference is in fact twice the value of the coefficient in front of the n squared term. And there's the proof. So we can take that value when we get that second common difference, halve it, and we've solved the value of a. The rest of the process is to then subtract the effect of the an squared term from the original exam sequence and work on to just then consider the remaining sequence as a linear sequence and find the coefficients of b and c. And there you are.